consists of two groups: EVAPTech, which serves the wet cooling market, and EVAPCO BLCT dry cooling, which serves dry cooling requirements for power plants. Together, EVAPTech and EVAPCO BLCT dry cooling are able to handle all cooling requirements for the power generation industry.
EVAPCO Power Group is about advancing cooling technologies for the electric generating industry. We have assembled a highly experienced group of industry experts and invested millions of R&D dollars in a state-of-the-art research center. Our goal is to develop next-generation technology for wet cooling tower systems, dry, air-cooled steam condensing systems, and hybrid systems. This short video is provided to showcase EVAPCO's air-cooled condenser test facility, which is the only one of its kind in the world.
The technology used on air-cooled condensers has been around for 20 years. It's time for something new. And the only way you're going to get something new is by aggressive research and development.
Industry experts like Dr. John Malbesh are very excited about what EVAPCO is doing to advance air-cooled condenser technology.
It's very rare to be able to test components of power plant systems at full scale. The degree of control, of instrumentation, and of the ability to vary both the geometry of the heat exchangers and the operating conditions of the heat exchanger is remarkable. Whereas there are labs, industrial labs, academic laboratories that can do this at bench scale. I am unaware of the existence anywhere in the world of a facility that can do that on these heat exchangers at full scale. I think there is great potential for this laboratory to help ACC owners make appropriate decisions and then to solve their problems. The existence of a facility to be able to test these units at full scale will be an enormous contribution. It will aid EVAPCO and the industry at large in being able to move in the direction of innovative improvements in the air-cooled condenser field.
Well, we want to test a full-sized air-cooled condenser tube bundle. So we've designed a facility that can accommodate a air-cooled condenser tube bundle that's 8 feet wide. 8 feet wide is a typical bundle width for shipping reasons. We designed it to be able to test one full-size bundle. In order to do that, it required that we build a wind tunnel test cell that's it's over 35 feet wide by 70 feet long, so it's quite a facility.
This kind of heat exchanger in the past has been tested in a small scale, has been tested with water inside the tube, but that kind of testing does not describe everything that happens in terms of heat transfer. By building a test laboratory that allows us to test a full-scale, full-size heat exchanger in the same conditions as in a power plant. They condense steam at a relatively low temperature, relatively low pressure under vacuum. And being able to test the heat exchanger with steam under vacuum is unique.
The process of testing full-scale air-cooled condenser bundles begins with the boiler loop. The heat load is provided by 3 propane-fired boilers which create hot water that is fed to the steam kettle boiler. The hot water transfers a portion of its heat, generating steam, which exits the kettle through the upper manifold and flows out through the large diameter steam duct to the top of the air-cooled heat exchanger. The steam is condensed in the air-cooled heat exchanger, where it is collected in a condensate collecting manifold and drains into the condensate receiver. The condensate is then pumped back and recirculated to the steam kettle boiler, completing the loop. Also leaving the lower manifold is a pipe that leads to a second stage surface condenser, which is a water-cooled shell and tube heat exchanger. The steam that's drawn to it condenses and is also collected into a condensate receiver and pumped back to the steam kettle boiler. A recirculating wind tunnel controls the velocity and temperature of the air supplied to the heat exchanger bundles. Intake dampers allow fresh ambient air to be drawn into the wind tunnel. Two variable speed blowers propel the air around the wind tunnel. The air flow rate is measured accurately through a wall of air nozzles. The air then makes a turn, opening to the tall side of the tunnel, and goes through a series of distribution screens and an air straightening section. The air is uniformly distributed as it approaches the heat exchanger. As it passes through the heat exchanger, the air is heated. The hot air leaving the heat exchanger can be exhausted from the wind tunnel, or it can be recirculated and blended with fresh ambient air to control the air temperature that's circulated back to the inlet of the heat exchanger.
As part of their R&D efforts, EVAPCO has an ongoing partnership with Dr. Pega Herniak and his company, Creative Thermal Solutions. Through this partnership, CTS provides rapid small-scale prototyping and testing of new heat transfer concepts. Favorable concepts are then developed into full-size product for validation testing at EVAPCO's full-scale test facility. CTS also assists EVAPCO by investigating and validating different protocols of brazing and manufacturing techniques.
My name is Hui Zhao. I work here as a senior research engineer at Creative Thermal Solutions. So my job activities is really mainly related to aluminum brazing and brazing of other advanced materials. Here in this brazing lab, we use the transparent glass furnace to visualize the brazing process, and therefore we can learn how the brazing conditions such as the heating ramp, peak brazing temperature, background atmosphere, and as well as the material selections can influence the final quality of the products. And then we can transfer this knowledge into the manufacturing process using our continuous brazing line. And we also have the state-of-the-art measurement technology for the temperature profile inside the furnace, which is really a data pack system that can track the temperature of the brazed parts when they are going through the heating zone of the continuous furnace.
It is very exciting for me to be part of EVAPCO's extreme commitment to technical research, development, and validation testing. This helps assure that our customers can purchase air-cooled condensers with known thermal performance capabilities while enjoying the benefits of innovative new heat transfer technologies. I invite anyone working within the power industry to visit our Maryland Research and Development Facility in order to witness our innovation in action.
Call EVAPCO at 410-756-2600 and visit our website at evapco.com. For dry cooling inquiries, call EVAPCO BLCT Dry Cooling Incorporated at 908-379-2665 and visit their website at evapco-blct.com. For wet cooling inquiries, call EVAPTEC at 913-322-5165 and visit their website at evaptec.com.